Hi there, welcome to Chapter 11. Today what we're going to be doing is looking at predicting winning percentage, and that's all about what Chapter 11 is, making predictions. So in this chapter, we're going to learn how to use relationships between variables to make predictions and seek explanations. We're going to start by exploring what it takes to build a better baseball team. We know the ultimate goal of every team is to win games, and some teams win more games than others. Since scoring more runs than your opponent is the key to winning games, it makes sense to investigate the relationship between runs scored, runs allowed, the other team scores on you, and winning percentage. Now, Bill James is one of the original and most famous sabermetricians, and a sabermetrician is someone that uses statistical methods to analyze specifically baseball. Anyway, he proposed what's called the Pythagorean expectation of winning percentage, and this is his formula. First of all, let me tell you what these represent. RS represents runs scored, and RA represents runs allowed. So again, runs scored are how many points your team is scoring, runs allowed are what the other team is scoring, okay? And it's going to be a fraction. And what we have is we have runs scored squared in the numerator. And in the denominator, we have runs scored squared plus runs allowed squared. Now, one thing I'm going to have you guys put here, when you enter this into the calculator, you really have to put this denominator in parentheses, or else you'll divide runs scored by runs scored and then add the runs allowed, and that's not going to be no good. But this is what we're going to use. So for baseball, that's we use the Pythagorean winning percentage, and just like in the Pythagorean theorem, it's like three things that are squared, the same thing for this. So let's consider the stats for the 2008 Detroit Tigers, who scored 821 runs and allowed 857 runs. So first, let's calculate the Pythagorean predicted winning percentage. So again, our predicted winning percentage is going to be runs scored squared over runs scored squared plus runs allowed squared. You don't have to write that each time. But let's put it in. So here for runs scored, this is going to be the 821. So I'll put 821 in for runs scored. And then here they allowed 857 runs. So let's put that into runs allowed, okay? And again, what we want to do is make sure that this is in parentheses here, okay? And so then we can just put that into the calculator. So we're going to have 821 squared divided by, in parentheses, 821 squared plus 857 squared. And that gives us about 0.47, sorry, 0.479. Again, we usually round proportions to the nearest thousandth. So that way, if we turn it into a percentage, it's to the nearest tenth of a percent. So that gives us about 47.9%. So now letter B says we're going to find the predicted number of wins using the fact that they play a 162 game season. So what would we do for that? What we want to do is to find the predicted number of wins. What you're going to do is take the predicted winning percentage in its decimal form and then multiply it by the total number of games that are played. Okay, so here we said that our predicted winning percentage was going to be, as a decimal, was going to be 0.479. And now they're telling us that they play 162 games. We're going to multiply that by 162. So I'll take 0.479 times 162, and that gives me 77.598. And there are different schools of thought about rounding. We're just going to practice traditional rounding rules. And this 5 is going to bump that up to 78 games. Okay. So we'd expect them to win 78 games. So that's the prediction that this would make. Well, what actually happened back in 2008 back in 2008, the Detroit Tigers actually won 74 games. How does this compare to our prediction? Well, we noticed that our prediction was 78, so it was off by 4 years, or by 4 wins, I should say, for games. Okay. So we were off by 4. And that's going to happen sometimes when we make predictions. Sometimes when we make predictions, we're going to be off. And that has a specific name. The difference between the actual number of wins and the predicted number of wins is called a residual. Okay, so when we calculate our residual, we're going to take the actual value minus our predicted value. That order is important when we're subtracting, so we have to be cautious about that. So again, actual minus predicted. I always think alphabetical, A before P. Okay. Now let's say that your residual is positive. That means that the actual value is greater than the predicted value and your prediction was too low. When a residual is negative, that means the actual value was below the predicted value, so the prediction was too high. Either one could happen. Now let's think about it though. What would an ideal residual be? Remember, the goal is to make an accurate prediction. So the goal for an ideal residual would be for the prediction to match the actual. And if you subtract two numbers that are the same, we would get 0. Okay. So an ideal residual is 0 because that means you made a perfect prediction. Okay. Well, let's calculate the residual for the Detroit Tigers. Here we just set off by 4, but now we're actually going to give a sign. We're actually going to say if it's going to be positive or negative as far as this goes, okay? And so again, to find the residual, we're going to take, just to drive this home, the actual minus the predicted. So the actual was 74. Our prediction was 78. So that's -4. Okay. So that's our residual. Our residual then we can say is -4. And what this means is that they, because the residual was negative, that this means that they performed below their prediction. And we were trying to predict how they won games. So we can say that they won 4 fewer games than expected. And again, that was based on runs scored and runs allowed. So this idea is how we can interpret a residual. Okay. When we interpret a residual, we're just going to say what exactly happened. Was it 4 fewer games? Was it 4 more games than expected? And then also what we're basing the prediction on. We won't always make predictions just based on runs scored and runs allowed. Maybe we would make predictions based on home runs or something like that. So that's what this is. It just tells us what we're using. So sabermetricians often attribute these residuals to luck, or in statistical terms, random chance. So again, even if we're really confident in a prediction, random chance could kind of throw off what the performance that we actually see is. Okay. All right. So again, some argue the ability to win close games help explain the size of residuals, but we're just going to focus on finding the residuals. And so that brings us to this you try question. What I'd like you guys to do is take what we did in the on the front, on the last page, and consider these statistics instead. Okay. This is data for the 2008 World Champion Philadelphia Phillies. It says what they scored. It says what they allowed and how many games they won. So I'd like you guys to take a minute and calculate the predicted winning percentage, find the predicted number of wins, knowing they play a 162 game season, just like we did in our letter B. And then in letter C and D, we're going to find the residual and interpret it just like we did on the front here. Okay, so pause the video and let's see if you guys can do this. Okay, let's see how you guys did. For the predicted winning percentage, I ended up getting 0.580 or 58.0%. Again, I know that sometimes it can be uncomfortable when a 9 bumps the 79 up to an 80, but technically if we're rounding to the nearest thousandth, that's what we would want to have. Then we take the decimal and we multiply it by the total of 162. And now this is predicting that we have 94 games. To find the residual, we take the actual, which they told us here that they actually won 92 games, and we take our prediction of 94, and we subtract and we get -2. And that means that the Phillies won 2 fewer games than expected. And again, that prediction was based on runs scored and runs allowed. And that's pretty much what you're going to be doing this evening for the homework. Okay. So is there a better model? We've been using 2 as an exponent for baseball, but why did Bill James choose 2 as his exponent? There's a more general formula for predicted winning percentage, which still uses runs scored and runs allowed, but instead, we're going to have an X as the exponent. So we'd have runs scored to some power over runs scored to some power plus runs allowed to some power. And what you can do is kind of like try out different values. So you could try X equals 3. You could try X equals 2.5 and then see what the best one is going to do. So let's try a different number here. Instead of having a 2 here, let's recalculate our predicted winning percentage using X equals 1 instead, okay? So we're going to do the predicted winning percentage with X equals 1, okay? So that means that this is going to be, and again, I don't need you to do this, but we're going to have runs scored to the first power over runs scored to the first power plus runs allowed to the first power. That's what it means. We're just going to replace that X with 1. And they reminded us of that data. They scored 821 runs. And they allowed 857 runs. Okay. And we know that raising things to the first power doesn't change the value. So I can put 821. I'll just put it to the first power anyway, just to be dramatic. So divided by 821 to the first plus 857 to the first. Okay. And that gives us a different winning percentage. So this gives us 0.489. That 2 tells us to keep the 9. So this would be 0.489. Or we could have it 48.9%. I know a lot of us like those percentages better. So now with that as our predicted winning percentage, let's look at what the number of games, predict the number of games that they would win. So this is where we would take our predicted winning percentage as a decimal, so that 0.489, and now let's multiply it by the total number of games. Well, this is still the same season. Remember, they said that it was 162 games. So we'll use that number again for this question. So if we take 0.489 times 162, that gives me about 79 games. So that's our prediction. They're going to have 79 wins. So now let's interpret the residual. They actually won 74 games. Well, remember, for the residual, we're going to take the actual minus the predicted. So we have 74 minus 79. And so what that does is that gives us a residual of -5. Okay. And again, what that means is that the Tigers won 5 fewer games than expected. Again, based on runs scored and runs allowed. Okay, so that's our interpretation of the residual here. If the residual was positive, then we would say the Tigers won 5 more games than expected. So that's the only difference that you'd make if you had a positive residual. Okay. All right, so now we've done that with x equals 1. So which exponent, x equals 2 or x equals 1, appears to be better, and why? So if we look at x equals 2, remember when we did the work for x equals 2, our residual was -4. And with x equals 1, our residual was -5. Okay. They're very close, I know, okay? But which one is going to be better? Remember we said that an ideal residual was 0. So which of these is closer to 0? Which of these is closer to being perfect? This one. And so what we can say is, again, we're not going to give the residual, but we're going to say that x equals 2 is the better exponent of these two, at least. And as far as why, we can say because the residual is closer to 0. Okay, but that's what we're looking at. What is going to be the closest one to 0? Okay. So that was just using the Detroit Tigers to decide that 2 was a better exponent of 1. To decide if an exponent of 2 is really the better exponent, what we would want to do is we would want to look at the residuals for all the teams, not just the Tigers, to compare those predictions. And that has a specific name as well. This is called the sum of squared. Sorry, I got cut off. This is called the sum of squared residuals. And that's another way to measure how well a model makes predictions. The sum of squared residuals is referred to also as SSR. And what it is it's this summation notation symbol. I don't know if you remember that, but this means that you're going to add everything together. And then we know that actual minus predicted are the residuals. Now, the thing is that, remember, residuals can be positive or negative. So if we just add the positives and negatives, those are going to kind of cancel out. So what we do is we square them. And that's really what it is. It's the sum of the residuals squared. Now, you'll never have to calculate that. It'll just be given to you. But just know that when you're given a sum of squared residuals, that we're basically looking at the residuals for a whole group of things instead of just one particular data point, okay? So if a model makes good predictions, that difference between actual and predicted values will be close to 0, like we said. And what that means is that's going to result in a small sum of squared residuals. So just like when we were looking as far as being closer to 0, because residuals can be positive or negative, the sum of squared residuals is always going to be non-negative because we squared everything. All right. So for this one, we can say that the SSR is smaller to find the better exponent. So this says with an exponent. Sorry, it cut me off again. With an exponent of 2, the SSR for all the 2008 teams was 529, while with an exponent of 1, the SSR for all the 2008 teams was 1215. What exponent is better and why? So I just started organizing this information. With x equals 2, the SSR was 529, and with an exponent of 1, it says that the SSR was 1215. So which one is going to be better? Again, in this case, the one that's closer to 0, and because we're dealing with the sum of squared residuals, we can say the one that is smaller. So we can say here that an exponent of 2 is better because it gave a smaller SSR. And you can also say an SSR that's closer to 0, that's fine. And that way you can use the same reasoning for each one. But that is the gist of our lesson, Chapter 11, Topic 1. So that's what you guys will be doing today, is you'll be finding predicted winning percentages, finding the predictions, the residuals, and interpreting. So have a great day.